Okay, hello everybody. Welcome to this session. I'm Martin Wynne, the National Coordinator for the UK, chairing this session. I want to introduce Lonneke van der Plas, who's our second invited speaker at the conference. It's very nice to have her here. I've met her for the first time here, but she does have some long-standing connections with CLARIN. She worked for a long time to try and get Malta to join CLARIN ERIC, and she played a leading role in the Upskills project as well. So I think many of you already know her and have worked with her. She currently works at the Università della Svizzera Italiana, and has also worked in the Netherlands, Germany, or worked and studied in Netherlands, Germany, UK, and Australia. And I'm very pleased to introduce her today, and she's going to talk about creativity and AI.
Thanks a lot. Thanks a lot for inviting me. I'm super happy to be here, super honored to be here. Thanks also a lot to the local organizers. It's been such a wonderful experience here. It's been really, really nice. So yes, I'd like to talk to you about creativity and AI today. But before we start, I'd like to go back to where it started, actually, because, yeah, as you were saying, moved to many places during my academic career, but I also am in the field already for a long time, and I'm in the field of natural language processing. And I just wanted to say that when it started, it was like that. When I did my master's, and I was the first time that I got in touch with something that wasn't even called natural language processing yet. We were still having these kinds of mobile phones, and some people were using Hotmail for their emails, and yeah, Google was the search engine, but it looked very different back then. Well, a lot of things have changed, actually. So back then, it was still really seen as a collaborative or an interdisciplinary field, with computer science on the one hand, linguistics playing a big role at that time. And yeah, we were all clear that NLP gives computers the ability to interpret, manipulate, and generate human language, and it allows humans to interact more naturally with these systems. But also, we could model linguistic processes and find patterns in large amounts of data to learn something about linguistics. So where we are now, things have changed so much. As you can see here, the number of papers in our field have increased dramatically, and it's maybe not a surprise, but back then I still had to explain to everybody what I was doing. Nowadays, I don't need to explain it. Everybody knows this or has experience with our field. And it's not a surprise because, language is a very important thing. We can do lots of things. We communicate through language with each other. And we can automatically extract information from textual documents, classify them, summarize them, use them to predict things for the future, and we can generate text. And this is largely also thanks to, of course, some main breakthroughs that we made in the architectures that we're using for our models, with the neural methods and the transformer coming up recently. Yeah, it's also one of the most wanted types of AI currently in business. So we also have this, that we have a lot of requests from business to help them with NLP. But what is a pity actually about this, and if you look at this, the number of papers, the other thing to look at is the number of people that go to our conferences. So I was here a few months ago for ACL, also in Vienna. It wasn't as enjoyable as this conference, I must say. It was in a very big hall. We had, I don't know, so many posters that I actually never saw a poster because it was just too much. You would meet people on the way, but you never reached the posters. So not as enjoyable. Also, not this feeling of a community that I have here. So I'm really happy that that we have that here. Actually, I wanted to say that. Also, I think for students it's hard in these days because the field is moving so fast. They feel a lot of pressure, actually. Not as in my case, I had some things that I thought were great ideas back then, as all PhD students have, I think. And I had time to think about these ideas. And that was nice. But my students are all in a rush. They want to publish. They want to put it on archive before somebody else comes and scoops the idea. So it's a little bit difficult, I think. So with the change of NLP playing such a big role in our daily lives, when you see that, as I said before, it was like Google was the one thing that I always gave as an example when people said, what are you doing? Language and computers. So why? What? Well, do you use Google? Yes. Okay. So then I had a thing. Now there's much more people using automatic translation. Amazon uses also in the back of their systems NLP. There's of course ChatGPT, right? So now everybody is much more in touch with all of these NLP methods. With that come also quite some problems, right, related to privacy, bias. We've heard it already yesterday. Explainability of results, trustworthiness, and also the sustainable development, because these models request a lot of resources to be trained. So for me, I'm currently actually the domain looks a little bit like this, or maybe we're going already actually in the right direction. But NLP is kind of, taken up by computer science, and there's still linguistics, but it's not playing such a big role, and that is, I think, is a pity. And what I feel we should be going into what is more a thing like this, a very interdisciplinary thing. Since we have all of these systems being used by so many people, we also have to think of the ethical aspects. Law is involved, there's the life sciences that should be involved, and cognitive and social sciences, I think. And this is what I found here so great, is that actually CLARIN is doing that, right? You're bringing communities together, creating this nice collaboration between different fields. And I think this is, at this moment, very crucial. And actually, I must say that at the ACL that I was last few months ago, it was also the case that I saw many more people coming from other fields also contributing to the NLP field. Good. So yeah, CLARIN has a role to play here, not just in teaching students, right? We've talked about the Upskills project, which I was involved in, but also collaborating with colleagues in other disciplines and collaborating across sectors, also something that you're focusing on. So all very good. So that was the first part of my talk. So the rest of my talk, I'd like to talk to you about something that I've been working on recently, where there's been also a lot of collaboration. In this case, it was mostly with cognitive scientists, and that is creativity and AI. And I'll start by telling you, why did I want to work on creativity? Why was that so important for me? Well, it wasn't because I thought that computers should be able to make paintings. I love painting myself. I'd rather not have the computer do that, actually. But it was there was another thing behind that. So when I was looking at how the society works, and I thought of how a traditional society works, there's a lot of people with a lot of ideas. They're all different. They all have their different backgrounds. They come from different places. They have different ideas. So the ideas are very diverse. And what happens with these ideas? Well, people make mistakes, of course. Think of restaurants that are being opened, right? Some people have maybe a crazy idea for a restaurant. I don't know. Is there in the Netherlands a restaurant for insects? Would that work? Would that not work? I don't know. But somebody had the idea and tried it out. Perfect. So the nice thing about all these different ideas and people with crazy ideas is that we get a lot of diversity. And by diversity, we're creating learning potential. There's innovation. People are able to adapt to different situations. They're more flexible. Now what happens, yeah, if you have AI systems? And this was work that I've done actually in 2019 or 2020, right, with Michele Loy and Eleonora Vigano, who are both ethicists. We thought, the society as we look at it currently, well, it was back then, before ChatGPT even, people are relying more and more on these systems to help them with decision making. So it means that all these people with their diverse background kind of blind a bit to that and just go to these systems to give them ideas on what decisions they should make. And many people go to the same AI systems. So what happens in that case? Well, definitely, I think one thing we may have gained is efficiency. We're more efficient. And this is also why people keep using these things. Oh, I get things done much more quickly than I used to do before. But there's a lot less diversity and there's less exploration power because there's just not that many different things being tried out. And that makes us much less flexible and also, I think, very vulnerable, because I mean, imagine that one of these systems makes mistakes, or even if one of these systems doesn't work anymore, a lot of people will be like, what do I do now? I think this is a problem. And if you think of what have been said already, maybe you've heard about it, but these systems are trained, right? They're trained on data. And the data they're trained on, they're trying to not make mistakes, because that's what we try to train them for, right? You have the objective function, try to do what you should do in the task as well as you can. If we keep training them and we keep using them, the things that the predictions that it will make will be based on the actual things that we do currently, which could be informed by these models. So we get this kind of, learning based on data that they themselves created. So you can imagine that the world could become a very boring place. So this is where it started, and I thought we should do something about that. And so I have 3 different topics that I would like to talk about, and they're all at the intersection of NLP, linguistics, and the cognitive and social sciences. So the first 2 I can't spend that much time on because I have a limited time, but the last one I'll spend a little bit more time on. So sorry that it is quite a lot of stuff, but there's just a lot of things that I'd like to talk to you about. So the first thing that I talked about, one thing that always intrigued me, is that people come up with new words. I really love this aspect of language. People, things change in the world, and we come up with new concepts and create new words for that. So one thing that we've been studying in the Evolving Language project, which is an NCCR in Switzerland, we have these large interdisciplinary research frameworks where multiple universities and people from different disciplines work together. And we're all working on trying to solve this, like trying to answer the question of how does language change, where did it come from? So we have people from animal communication, people from neuroscience, people from NLP, linguists, all together talking about that. So I have a tiny task in there together with my PhD student, Diego Rossini, and there are 2 people from the UZH. One is a computational linguist, Lena Jäger, and Andrea Miliano is an evolutionary anthropologist. And what we're doing there is we're looking at the emergence and spread of neologisms. And because this is an interdisciplinary project, we're not only looking at Western societies or the so-called weird societies, but we're also going to look at hunter-gatherer societies. So this is, of course, you can imagine that that last part is the one that we're a little bit worried about. We still have to see how we're going to do it, but it's also very exciting. For the Western societies, well, we just went and find social media data, and we looked at terms and tried to, now what Diego has done, he found the terms that seem to be neologisms based on how they behave, their frequency and all that. And then we're going to look how these words are spread in the communities across Reddit posts. And yes, then he should go sometime in spring, maybe, to the ACTAs in the Philippines and try and see how these people come up with new words when there are new things in their communities and how do they spread. And yeah, if anybody has experience with that, it would be really great to talk about that, because there I don't have that much experience. So that's the first thing. So this whole idea of coming up, of trying to find out about new words and how they come up in language started with some work I did much longer ago, together with Prajit Dar and Inga Lang. We were trying to predict compounds, and compounds are really great. I worked a lot on compounds because with compounding, which you can do in English, for example, you take 2 words that you know very well, you put them together, and you create a new word. And we said, can we maybe predict what new words people will come up with? And then, of course, the problem of evaluation crops up, yeah, because you're going to generate things. How are you going to say it's a good term or not? So we thought, maybe we can be clever and say, we take a timestamp corpus, we take the first part for training our models and the last part for evaluating. We just mask it. The model can't see those terms, and we're going to see if it can predict those terms. So a vector-based model and some supervision onto what are good compounds and bad compounds, and we could do that by just taking good compounds from the corpus and creating shuffled versions of that, pretending that these are bad ones. So we had the coffee machine as a good one because we've seen it, and then we changed the machine for the mouse, and we said a coffee mouse, that's a bad example. Of course, it doesn't always work. Sometimes you get good examples, but this is how we trained our model. And then we predict new ideas. And in this picture here on the right, you can see what the system predicted. So that's the things in red, and then the things that are found in the evaluation set, which is the last part of the corpus. And in the middle, you find the things that, it should have predicted, and it did predict. Vaccination law, infection outbreak. Yeah, it seems to be a bit related to that time of our that period, right? Other things were actually not found in our evaluation set. Somehow it didn't appear in that 2015-2019 window. But some were perfectly fine, like Riesling sauce. I thought, yeah, why should we count that as incorrect? And cheeseburger spread, Kevlar jacket, I thought, not so bad. Some were a bit strange, like brain sculpting, the knee-length glove. Well, where did that come from? A light-emitting lamp is also a very special kind of lamp, I think. So that was maybe not the best one. But the melting cloud, again, I thought, this could be used in an artistic way, maybe, or yeah. So evaluation, a hard problem with creativity. That's what we learned from that. So then the other thing that I'd like to quickly go through is some work that I'm doing currently with my one PhD student, Molly Peterson. And that is analogical reasoning, very important for creativity as well, because it helps us to generate new ideas, also to explain complex concepts to people. And you may think, well, wasn't that a solved problem already? Didn't we have Word2Vec who could do things? And wasn't there the man is to king as women is to queen, and it did that already very well? Well, yes, but that's not all there is to analogical reasoning, right? So analogical reasoning, as you see it here, is modeling this relationship, for example, between, it will say something like A is to B as C is to D. So man is to king as woman is to queen. And the kind of things that people in NLP have been doing are a bit simple. Yeah, you must agree with me, like, entertain is to entertainer as examine is to examiner. Yes, okay, and the man is to king. It's always the same kind of pairs with the same kind of relationships between them. And also these relationships can be verbalized quite easily, right? Bit like morphological patterns in a way. But analogical reasoning is much more complex. We can have very complex constructs, and here's just an example. And for example, the solar system and the atom, we can compare these to each other, and there are multiple items in there that are linked to each other because the relationships between these individual entities in these two domains that are very different are actually related. And these kind of analogical reasoning data sets, let's say, so this is from the scan data set, are actually harvested from text and used to also test analogical reasoning in humans. So we decided to work on these kind of more challenging text. And what we did is we tried to see not if the models already have analogical reasoning in them, but also if we can kind of make them be better at analogical reasoning by trying to train them to not focus so much on entity similarity. So, I don't know, a chair is very similar to a sofa, but thinking of relationships more. Like, there are a lot of relationships between things around us. Let us focus on the relationships, change the objective function, and yes, it turned out that actually by doing that, we could do analogical reasoning in a better way. And you can see that from these results here. So a simple classifier wasn't doing as well as training BERT with this idea of focusing on the relationship between the A and the B term, how it's similar to the C and the D term. Okay, and we'll have a tackle review soon that's going to come out, and it's a collaboration with Claire Stevenson from the University of Amsterdam, who's our cognitive scientist. And here we're looking really into analogical reasoning, how it's differently handled in the NLP community as it is in the cognitive science community. And what we've done, for example, is we looked at all the main processes that we find in analogical reasoning. So, for example, there is retrieval, there's the mapping aspect, the re-representation aspect, then there's abstraction. You have to abstract to be able to find an analogy, and there's the encoding as well. So these are all the different aspects that we find in cognitive science, but if you look at the NLP literature, people haven't really focused on all of these processes that we find in analogical reasoning in the same way. Some have been given a lot more attention than others. And also, there are different types of analogies. I already showed you the simple entity level analogies, like the queen and woman and man and king. Also the morphosyntactic, the other ones like go is to going, asleep is to sleeping, for example. But there's also people working on symbolic analogies, just looking at alphabetical orderings. And the last one, which is one that people have now started looking into more and more, is these long-form analogies, right? Where you have a story and another story, and you have to figure out that there's an analogical reasoning between these two stories and find out which entities map, which relationships map. And this is, of course, a much harder problem that we're trying currently to build a data set for. So there's a data set, but when you look at the data set, we did some tests with it. It turns out that if you do just look at syntax and remove all the semantics, you're doing really great, better than the state of the art. And so there's a problem with this data set, right? So I think data sets are very important, and also, again, something where CLARIN has a lot of could help us a lot, building better data sets in collaboration with people from other disciplines, because that's how we figured out that it's not a good data set. So now we have some time for the last part of my talk, which is my other PhD student in the same project, the Ceiling project, sponsored by the SNSF, is about large language models and trying to see how creative they really are, and also seeing if we can make them more creative, possibly. So we have two things that we did here. So yeah, I said like evaluating the creativity. This was work done again with Claire Stevenson. And then we have also trying to make LLMs more creative on a suite of different tasks, again, together with cognitive scientists. So what we're doing here is looking at different ways of evaluating creativity in AI. And we have, Meta has produced a nice summary of all the ways in which AI and creativity come together, and there's a lot about evaluation as well. And what he found out actually by looking at all the different works is that if you look at short responses, so if you want to evaluate people on creativity, there's several ways to do that. You could do the alternative uses test. You say, brick, what could you use it for? And people have to think, yeah, well, could build a house. Well, that's not very creative, right? But other things, what could you do with a brick? Divergent association task. Come up with lots of very diverse things. Now, tell me 3 things that are super diverse. It's another task you can do with humans. And then the other one is, well, you have a cake, you have Switzerland, and you have cottage. What is the thing that is in common here? Well, it's cheese. Yeah, cottage cheese. Yeah, cottage Swiss cheese and cheesecake. Okay, so all of these things are made to test humans. But are these also good to test machines? Sometimes not, because machines have very different ways in which they function. And sometimes such creative things, I mean, they have been shown to work for testing humans because they correlate with other things that are really showing creativity. But for machines, being able to solve these tasks doesn't mean that they're creative. So there's a problem. So a lot of people have shown that actually, yeah, the machines are doing really well on these data sets. Well, maybe they've seen them in their training data, first of all. Maybe they're not good tests for testing machines. They're good for testing humans, but not for machines, because they have access to much more data and have all this memory. Maybe they can do it well because of that and not because they're creative. So we've been looking at long responses because we think that there we may get some more information about how creative systems are. So things that people have been doing there is poetry generation, but also creative story generation. We focused on the first one, creative story generation. So we wanted to know, are average humans more creative than AIs in story generation, and what are the key differences? So what we did, and this is again thanks to our collaboration with the cognitive scientist Claire Stevenson, we have 3 words, stamp, letter, and send, and we asked the person or the machine, tell us a creative story with these 3 items. Well, you can imagine with stamp, letter, and send, you can do some very boring stuff, right? I wrote a letter, I got a stamp to put on it, and then I sent it, right? Not very, very nice. But you can also try and make people and machines come up with creative stories. So what we did is we had 4 item sets, so the stamp, letter, and send, for example, and also petrol, diesel, pump. These are typical combinations of words that can lead to very boring stories because they're very much in the same kind of semantic field. And then we had organ, empire, and comply, or gloom, payment, and exist, where there's much more a high diversity in the semantic meaning. So maybe this would make people and machines come up with more creative stuff. So we had 60 humans that we asked to do this task, recruited from Prolific, and we had also 60 models. That was, we were quite impressed that we could do that. And then we instructed them to say, yeah, you are an expert, you have to create a story, and you have these 3 words to do that. And you have to come up with a novel and a unique story that uses the required words in unconventional ways or settings. So write a story using a maximum of 5 sentences, and it must include the following 3 words. However, the story should not be about and then boring themes. So we would give an example of what we don't want. Okay, so what do you get as output? So we can do a little Turing test here. So you ask for petrol, diesel, and pump, and you ask systems and you ask people to give us. And here you can read. The first one says, during one night at my local gym, I bumped into Vin Diesel, who commented on my ability to lift my weights correctly. He decided to show me a better way to get my pump on, and whilst giving a chance to ask him, I quipped if he had any siblings named after petrol. And then the other one, in the bustling heart of Mechanica City, where machines roamed free and humans were a rare sight, a curious little robot named Saphir discovered an ancient contraption labeled the petrol pump of dreams. Legend had it that this pump, when filled with either petrol or diesel, would grant a single wish to the one who dared to activate it, and so on and so forth and so on and so on. So maybe you can have a guess. You know, especially maybe because of all the dots, right? Like going on and on and on. You already discovered that the last one is actually a machine who created it. So we wanted to evaluate creativity with these kind of outputs that you saw. So we said, what do we look at really? And there you get the problem. I said somewhere in my abstract, I'm going to talk about how hard it is to evaluate and what the problems are with working on creativity. Well, evaluation is a big problem because there's so many different aspects of creativity. And people will say, but isn't it about novelty and about surprise? And then he would say, but it's not just novelty and surprise. You also have to have some sort of quality, because otherwise if I drop my coffee cup and it's novel stain that's created here is not going to be so creative, right? So there's all these different aspects. So we looked at different aspects and also asked judges, like human judges and LLMs as judges, to see how what they thought of it. And so one thing we looked at, because we were just curious about it, not so sure whether it's a real part of creativity, but still we thought maybe it has an influence, was lexical complexity. So just the sentence length and the readability score, we looked at that. And what you can see from these pictures here, so the dark ones are the humans and the AI is the lighter ones. The sentence length is much longer with LLMs. Also, in terms of readability, they're not doing so well. So they make very complex stories that are hard to read. And if we look at the average dependency path length, for example, we also see that, again, the machines here are much more complex in creating these diverse dependency lengths. Okay, I'll go on quickly. Part of speech use, a lot of use of adjectives, much different from between humans and machines. And the other thing we looked at is diversity. So that was complexity, then diversity. How many unique n-grams do we find over the total of n-grams? Here, the humans were producing much more diversity. So humans are more diverse in the kind of output they create. And when we look at the most common 5 grams, you really see a pattern appearing. So humans have some things that we've seen twice. Of course, it's a large data set. But AI, in the heart of, together 53 times. So there's something about in the heart of that I really like. So there's really not a lot of diversity. Inverse homogenization score was then also looking at semantic diversity. Here we're trying to look at the average pairwise distance of a story to all the different stories written on the same set of items. So all about stamp, letter, send, for example. A lot of difference here, right? So humans are producing very different results than the AIs do here. So LLM stories are semantically less diverse than humans are. Novelty. LLMs produce less original stories. We're looking at the novelty of the story compared to other stories in the same data set. And then surprise, something else, which is also important in creativity. Yeah. So if you go in a story, at some point you want to be surprised, right? That's the creativity. Here we also saw a big difference again. Humans create much more surprise in their stories than machines do. And if we look also at the surprise profile, as we go from one sentence to the other, we see that the machines stay on a bit monotonically, not very surprising. And humans, at the end, they have this like surprising thing. And this is what we see. When we asked the judges, we asked non-experts, we asked LLMs and we asked experts to tell us what they thought about things, like how creative, how original, how surprising was it, and also how effective was the story. And we did this Turing test. Can you tell whether it's a machine or it's not? We got the following results, which I think are very telling. So experts rate human stories as more creative. You can see it in the dark bars here. The experts are, the arrows are explaining where the experts are. Non-experts, however, and LLMs show an opposite trend. So they prefer the AI-generated stories. And a Turing test revealed that the experts actually were figuring out much more better when it was a machine or it wasn't than the non-experts and LLMs. Well, that LLMs like themselves, I could have expected that, but I didn't think that humans that are not experts would love them that much as well. Although on the other hand, yes, because I know that these machines are made to make us happy, right? So maybe that's what's happening. So we try to look at what are the driving factors actually. Why do people, why do certain types of judgments, what are they based on? And we saw that expert judgments are mostly driven by diversity and surprise. So if we see diversity and surprise, the expert said, this is a nice story, this is creative. While non-experts and LLMs were really very much influenced by complexity, which we actually thought wasn't really part of creativity, but somehow it seems that for the untrained eye, the complexity creates a sort of illusion of being creative. I don't have much more time, so I'll go quickly through the last bit, which is how we improve LLM creativity. So people have tried to improve it. They've looked at, as input, can we do brainstorming? Can we do multilingual prompting? At output, can we, like for the decoding, can we do temperature sampling, diverse beam search? And we said maybe we can use alignment. So you know that these models, generative models, are aligned to human preferences. We thought, could we make them, instead of, usually people make them useful or something, right? Try to optimize them for that. But it has been shown that when you make your systems very useful, they also become very, diversity is killed by that, yeah? So very useful, but not very diverse. So people have tried to diversify, but we said, can we maybe add all the other aspects of creativity as well? Because as we've seen in the talk now, there's so many aspects of creativity, novelty, surprise. We keep the quality, and then there's diversity and other things. So what we tried is to create a creative preference optimization that uses a kind of weighted sum of all of these different aspects that we found in our work to be very important for creativity, such as novelty, diversity, and surprise, but also quality, and try to see if we can, weighting one thing, optimize for novelty, weighting one diversity higher, get things that are very diverse. And we have a very nice data set, which may interest people. It's a multilingual, multitask creativity evaluation set. 25 tasks, 11 languages, many prompts, many responses. And you can see the diversity of tasks. We got this by asking the community and asking also, looking in what was available for us in the open science framework, and we found these things. And just a quick glimpse at the results. So we found that when we just do supervised fine-tuning, or we just do a DPO, so a direct preference optimization, without these specific inputs of creativity, we do not usually as well on, for example, novelty, as our system that has the creative preference optimization that is specialized for novelty. So we can kind of, by making sure that the system is more giving preference to things that are more novel, it also creates more novel things on a held-out data set. So we can really train the system to be attentive, to be more novel, or to be more diverse, for example, or to be more surprising. And the nice thing about it is we do that without compromising quality, because there is a trade-off. I mean, you can be super creative, but then maybe the quality goes very much down, right, of the task that you're doing. In our case, we could balance it pretty nicely out. And that was just held out data set and held out prompts. But we also thought, let's do something where we really ask humans, like output of our system, what do you think about it? And we compared that to the big models like CPT 4.0, for example. And we found out that actually our model that uses novelty, diversity, and surprise at the same time is outperforming all of these big models also in terms of their creativity. We asked humans, which one did you find more creative of the two? And they chose the output of our system. And this can be seen in our, we'll have in findings of EMNLP coming up soon in China. You can find this. So to summarize this last bit, we have found a flexible preference optimization method where we can prove LLM creativity, a large-scale multilingual multitask creativity data set, and promising results on this automated and human evaluation. There's also an external evaluation. So yeah, that brings me to my final thoughts. And I hope it wasn't too much information anyway. There's the papers, of course, where you can read more about the details. What I think is very crucial is that at the moment, where we are now in the field of NLP, there is a clear need more than ever to work together across disciplines. As I said, social sciences, I've given some examples for here, linguistics, but also legal fields and even I think the life sciences as well. And one thing that I shown, hopefully, that is an understudied aspect of AI ethics, I think, is the reduction in diversity that we see and in creativity and the influence that it can have and a negative influence on society due to this. Then I've shown you some examples from my work. So I showed that we study creativity of human language and that of machines. And we try to also incorporate aspects of creativity in machines to make sure that, well, if people want to use these systems, and they seem to be using it even for, I met somebody who said, you know, I wrote a poem for my wife using AI, I mean, she didn't like it. I was like, yeah, okay, can imagine that, being a wife as well. But yeah, people seem to use these things, which I always thought, yeah, nobody's going to use that for creative stuff, right? Because and I was more worried about people using search engines because, you know, also there, you go for efficiency, you find what you're looking for, you never find what you didn't look for, like what you would do if you go to a library and, you know, you wander around and, hey, I never thought of reading that book. So I was more worried about these things, but now I see that even for creative tasks, people use these systems. So I think it's important that we make sure that the systems have some creative aspects. And we've shown you that I'm working on lexical innovation, so that's a very nice collaboration maybe with the first invited speaker, because he was looking also at how words change over time, so it would be great to collaborate. Analogical reasoning in the second part of my talk, and then the generative creative tasks at the very end. So thank you so much for your attention, and welcome for questions. Thank you.
Okay, thank you very much. Yeah, we've got a small amount of time for questions, so keep your questions short, please, and only one question per person. I think Kirill was first.
And we assume that people can have longer plans, and this is how they are better than language models, which have to tune it, the plans on each step almost.
I didn't get the first part of your system. What should we?
The people can have longer plans, how to tell a story.
I still didn't get it, sorry. Like a
well,
plan?
I know what is the end, will be the end after 10 steps. And language model has to change almost on each steps.
Ah, so it has to do with planning, you say, like when you have a story. Mm-hmm. Yes, there are indeed people that are using planning as like the first step towards creating a story. It's true that when we create a story, it's not that we just go from one sentence to the other, which we did in our study. It's true that it may help systems to think first, like, okay, what is the what steps do I take to create a story? And we actually thought of asking people when we asked them to create the stories, like what are the processes that you follow to create a creative story, but we didn't do it. But it would have been interesting because then we could have seen if people say, well, first I see those 3 words, I come up with a plan of what I'm gonna do, and then I'll invent it. Yes, I think that planning is indeed an important aspect, and we didn't touch that in this work.
Good, thank you. Next question over here, please.
Yeah.
Talk. I'll try to keep it short. One thing I wanted to inquire about is whether in this short story experiment, whether you have looked at a model size. That's one thing. And the other thing, model personality. Is that something that you think might have an influence on the result?
Yeah, that's a good thing. Well, we had different models, different sizes. Like we had 60 models, so we had all of the different models and in all the different sizes. So for each model, we had the different sizes there. But I don't have at the moment the results of the. I think we didn't really find much difference. We just took it in such a way that we said, okay, we have different people as well. So 60 different people. Let's also have 60 models because they could all be representing a different person.
I'll just explain. My hunch would be, I've already heard part of this presentation at ICCC already.
Oh, yeah.
And I think I asked the same question there. Anyway, my hunch would be that perhaps for some creative tasks, smaller models might actually perform better than larger ones. For the simple reason that you mentioned yourself, the alignment, they might be less aligned and hence more creative. So that's what I wanted to know, whether you have any plans of looking perhaps into that.
Yeah, that's something that we could do. And I think that was my PhD student who gave the talk back then. He didn't report back to me on this, but yes, I think it would be really interesting to look also at model size and see if that makes it as a factor in how they perform and how creative they are. And the other thing about the personality, this is something we tried, but we weren't very successful with that, we just said, like, you're a creative writer and do a creative. We didn't try different persona, but it could have an influence. We haven't looked at that. Thanks for the suggestion, yes.
Yep.
Yeah.
Thanks for the talk, and thank you very much for keeping linguistics in the loop.
Yeah.
And actually what I would like to mention is that last year at Euralex conference, we had a very successful workshop on AI and lexicography. And there we had a discussion, what shall we do with what the lexicographers should do with the words invented by large language models. Should we keep them in the dictionaries? Should we treat them as being equal as the neologisms by humans? Or what shall we do with them?
That's a very, very nice question. Thank you. So, well, first of all, how would you discover that they are created by large language models, right? You have ways? Oh, he needs the microphone. You have ways to...
Well, actually, that was a paper I published in 23 in a workshop on derivative morphology, on computational processing of derivative morphology. And actually, you can find, at least the methodology was that you treat the parallel corpus, you take the parallel corpus, and one half of parallel corpus you could translate back into the original language by a neural machine translation system. And there you find that there's a discrepancy between the original human text and the translated NMT system. And you can tackle where are the discrepancies in completely new words that do not exist in any dictionary, nowhere online could be found, and so on. You can find the paper.
Okay, that's nice. Okay, so yeah, okay.
We'll take one final question from Karina over here.
Okay, yeah. And not...
I wanted to hear your thoughts about language vision models, because you talk about creativity, and I'm just wondering, how do you see the direction of trajectory when you say interdisciplinarity, but also fusion of different sensorial inputs?
Yes, that's definitely... I went a little bit in that direction at some point when we were doing... trying to figure out what the meaning of compounds is. So compounds have this interesting thing that you can put two words together and the relationship is not specified. So, cheese knife, it's a knife for cutting cheese, but leather scissors are not also no, the chocolate box is made of chocolate, for example, or made for holding chocolate. So you never know what the relationship is. And we've used multimodal models, and we found that we actually have better results if we use multimodal models, where we show what does a cheese look like, what does a knife look like, and then try to figure out the relationship. So there it helped already for compounds. And yes, for creativity, I mean, if you think of how people come up with stories, how people come up with new words, it is also a lot because of their embodied experience, of course. There's a lot of things about texture, feeling things, which are not in these models, only in an implicit way, because we also find these things in language. So definitely it would be richer if we could use multimodal data. And I have not yet a project lined up for that, but it's something I've worked a little bit on in the past in this paper, and would be interesting to get to that. Thanks. Yes.
Good. Thank you very much. There remains one final thing to do at the end of this session, which is to give you a gift. And,
thank you very much.
And thank you again for the excellent talk. So thank you.
Thank you. Thanks a lot. Thanks, everybody. Yeah.